In this experiment, I am connecting flex sensor to one terminal of the flex sensor. It is connected to 5 volts supply pin of Arduino UNO, and the second terminal of flux sensor, it is connected to A0 pin of Arduino UNO, and the second pin is connected to 1 kilo ohm resistor, and from 1 kilo ohm resistor it is connected to ground. And in the same way, the servo motor output pin is connected to pin number 9 of Arduino UNO, and the VCC pin is connected to VCC pin, and ground pin is connected to ground terminal of on the breadboard. So the ground of servo motor and the ground of this flex sensor, it is connected to Arduino UNO, and VCC of servo motor and VCC of flux sensor, it is connected to plus 5 volt supply of Arduino UNO. Now the flex sensor is I'm not bending anything, so it is not, the motor is not rotating. Now I'll make the flex sensor to bend. See, the servo motor is rotated. When I bend the servo motor, see, the motor is rotating. At the same time, you can check the value in the you can check in serial monitor. Now the sensor value is showing 1023 and the servo motor is in a 90-degree rotation. Now I'll bend the flex sensor. So the sensor is showing 392 value and the servo is rotated to 0 degree. Again, I will bend the flex sensor. So it is 123 and the servo is rotating to 90 degree. So in this way, you can interface the flex sensor with Arduino UNO board using servo motor. So you check here. See, it is 90 degree and some sensor value. Again, it is showing 1023 and 90 degree. When I will not make the flex sensor to blend, it is showing some less value and servo angle is 0 degree. This is an experiment to interface a flex sensor with the Arduino UNO board. So what is flex sensor? The flex sensor, it is a type of sensor. It is designed to measure the amount of bending or we can say deformation in an object. So it consists of some flexible substrate with some conductive material on its surface. When the sensor is bent, the resistance of the material changes. So this change in resistance can be measured with the degree of bending. How in what is the degree of bending that we can determine with the help of this sensor. To determine the degree of bending, we are using servo motor. The flex sensors are widely used in human interface devices like gloves or other wearable technology to capture and measure the movement of fingers, hands, and other parts of the body. We use this flex sensor. They are used in robotics to monitor the bending of the joints. So this allows the robots to mimic the more natural and human-like movements. And they're used in medical devices to monitor and measure the movement of joints or limbs. And they're used in wearable devices such as fitness trackers and smart clothing to monitor the body movements and provide data for health and fitness applications. And they are used in some instruments and tools to measure the bending and deformation for a critical, whenever the critical situation is there, the deformation is critical for the performance and such, and they are used in industrial applications. So this is the introduction of flex sensor. So the figure in the image, you can see it's a very small structure and very thin, With the flex sensor alone, you cannot connect it to the breadboard. So what I have done on the back side of this flex sensor, I have cut the cardboard sheet and attached to the flex sensor, so that it will be fit into the holes of the Arduino UNO board. Otherwise, we cannot use it alone, because it is very thin structure. So how to connect this sensor with the Arduino board, and to measure the degree of bending, how to connect the servo motor, that I'll show here. So the servo motor has 3 pins. One is signal pin, orange one. Middle one is VCC pin, and the third one is ground pin. So the VCC pin is connected to 5 volts pin of Arduino UNO board, and the ground pin is connected to ground pin of Arduino UNO board, and the signal pin, which is orange in nature, it is connected to pin number 9 of Arduino UNO board, because in program we have used pin number 9. This is the flex sensor. On the back side, I have attached some cardboard sheet, and it has got only 2 pins. The first pin is connected to VCC pin, and the second pin, it is connected to the A0 analog pin, because it gives the reading in analog values. So you connect it to A0 pin, and from the same pin you connect to 1 kilo ohm resistor, and from 1 kilo ohm resistor other end it is connected to ground pin. So this is all about the connection of flex sensor with Arduino board and servo motor. In this experiment, we will write the code for flex sensor and a servo motor. Here we should include servo header file, and we will declare one variable, that is servo 1, and the flex pin is connected to 0, that is A0 pin of Arduino UNO board, and we are using serial monitor to see the sensor value. To check the sensor value, and the servo motor is connected, signal pin is connected to pin number 9 of Arduino UNO board. And here we are using 2 variables, flex position and servo position. Both are declared as an int variable, and we will read the flex pin value using the analog read and place it in the flex position. And after that, we will do some mapping. So after reading the sensor value, and when we place it in a flex position, so now we will map the flex position value. So the second line, servo position, this line. So what it will say, this will read the analog value from the specified analog pin, that is flex pin, and after that what it will do, this map function, MAP, this function, it is used to scale or map the range of values to another range. So we are getting some range of values from the flex pin, and we will map these values with another mapping values, that is between 0 to 1023. So, and it maps to the new range, and after that, after mapping, again it maps to the new range from 0 to 90 degree. The values 1018 and 1023 in the flex position range, if we get the value from 1018 to 1023 from this flex position after reading the analog value, then it will be mapped to the new value 0 to 90 degree. If it is in the range 1018 to 10123, then it will map to the new value 0 to 90 degree. So if the result is assigned to the variable servo position, so after that it is assigned to the new variable servo position. So what is this servo position? So the constraint function, this one, CONSTRAI, the constant function, it is used to limit the value of variable range. In this case, the servo position is within the range 0 to 90 degree. If the sensor value comes between 10 to 18, we are mapping between 0 to 90 degree. So 0 to 90 degree, and if this value is less than 0, if the coming value is less than 0, it will be set to 0 degree. The servo position is set to 0 degree. If the value is greater than 90, after mapping this, if I get the value greater than 90, then it will be set to 90 degree only. It means that the servo motor will take only two angles, either 0 degree or a 90 degree, whatever the value it gives. If it is less than 0, it is giving set to 0 degree, and if it is more than 90, it is giving the setting the angle 90 degree. So why we should set between 0 to 90 degree? Because this step it is used to prevent the servo motor from moving beyond its mechanical limit. So I have given the limit as 0 to 90 degree in order to limit the mechanical, in order to limit its mechanical rotation from 0 to 90 degree. We are giving the value 0 to 90 degree, so that the servo motors are commonly controlled within the specific range of angles. So this is the meaning of these three lines. After that, we will give that value to the servo motor to set its position, and we will print the sensor value in a serial monitor. Just now you saw that. And after that, we are printing the flex position also. What is the position, in which degree angle it is rotating. So what is the sensor value and what is the angle it is rotated. And after that, we are giving some delay between those two. So this is the explanation of the code for interfacing flex sensor with Arduino UNO board.